Hey guys, we are moving on to the third experiment of Internet Input Pulse Lab, and this experiment is about extended access control list or ACL. So we are going to do that using packet tracer as always. So here the given scenario is that two employees need access to services provided by the server, and PC1 needs FTP access while PC2 needs web access, and both computers are able to ping the server but not each other. So I have already made the topology as you can see here, and the components are functioning. So before starting up, I would like to let's see what's ACL. So as you can see here, access control lists provide a means to filter packets by allowing a user to permit or deny IP packets from crossing specified interfaces. So that is why we are using access control lists here, because the question itself is like providing only a particular type of access. So PC2 needs only web access, PC1 needs only FTP access. So in these cases, when we need only a specific type of access, we use access control list. So one of the simple ways of controlling the traffic, as you can see, is using access lists. So now the question is, what are the commands that we can use here? So to configure an ACL, we have two types of main access lists, that is standard access list and extended access list. What we are gonna discuss here is extended access list. So how do we differentiate between these two? Based on a particular number, we differentiate both of this. The number 1 to 99 is given for the standard, while the number 100 to 199 is given for extended. So for making it an extended access list, we make it as access list 100 then question mark. So these are the separate attributes which is used. So let's try it. So let's take the packet tracer. So here, if you are taking a router, let's try to configure this router. This just let's try to refresh it. Actually, it's other way around. I did mistake. So here, anyways, so talking about access list, one PC here needs FTP access, right? So here we have access list 100, then we have to permit, then the type of access which is required. So here what we do is like suppose we need TCP access. So here we have to use TCP because FTP requires TCP access. So what we have to do here is TCP, we have to add TCP after permit. So after that, if suppose we have to allow a particular host, so we have to add the host address. So we here in this case we have to add the host address of PC0 from router 0. Okay, so let's go back now. Similar to the case of OSPF, we need to find a wildcard mask. So as we can see here, uh, while wildcard mask is the binary opposite of a subnet mask, so that's how we find the wildcard mask here. And uh, after we have written the source IP address, uh, which is the host for PC1, we need to write the destination IP address. So destination IP address is this, and then we need to write how, like, uh, if we need to give only FTP traffic, we need to only provide the FTP port number. Like uh, after EQ, we give only the port number for FTP, so which is 21. So EQ FTP. Okay, so that's how it is done. And another, so the second PC which is required here says only web access, so it requires normal type of access. So for that we don't need to give any FTP access, we can simply provide ICMP access and bring it. So I think I have to start it again, so let's try it again. Extended period. Okay, so let's take this router, let's enable it, let's try to configure this. So while configuring this, as we already said, we are gonna take this this IP address. So what is the IP address of this? 172.22.34.64 as given here. So we are gonna take this and see what happens. So let's try to see what happens here. Just a second. Here now let's type the access list details. So access list, as I said, for the extended we have 100. Now we have to permit, so permit command. Now since it is a FTP, we have to give the protocol as TCP. Then the host address, so the host address of PC0 is this entire thing, so we give it as 172.22.34.64. And as I showed you before, the wildcard mask is for this particular thing is 0.0.0.31. This we find out based on the subnet mask, and then we have to give access only to a particular host, like the destination. So now we have to give the destination address, so we give the destination address like after the host keyword. So host 172.22.34.62, that is the address I've given for this. So now since I have to use FTP, so let's use FTP. Okay, so let's see, here we have to give a port number, so let's try 21. No, it's not written accepted. So let's try it without that. When you try it without that, Okay, it's still showing some error. So access list we have created. Okay, so I think the problem is in the keyword. Okay, so let's give it as access list. Okay, like this. So see, the main problem was in uh, the spacing problem. So now we are giving this as FTP. So now it should work for this particular host. Now the second requirement is that PC1 should have access to server 0 with simple ICMP. So that is simple web access. So we can do it as access list. Now we just have to change the addresses. So the host 0 address is 24 dot. Let's check the PC1's address. This is the PC1's address. So let's delete this, go back, and then okay, just a second. So again we just have to change the protocol here. So here we can use it as ICMP. Then we paste the address which you took from there. Then the subnet mask, we have to calculate the subnet mask again. Since it is 64, so 64. Okay, let's check whether the FTP thing is working or not. So close this. And now we go to the filters. Miscellaneous, we select the FTP and LLDP. And now what to do is we clear all the proper thing first, and then try to pin this and this using FTP. So as you can see here, it's successful. So this is pinged in this with just FTP access. So that's what is required here. Similarly, we can use the same configuration for this PC, and we find that it can access server 0 also. So that's it. That's what is there in this experiment. Thank you for watching this video.